Hello everyone, welcome to the another session on quantum computing. In this video, I am going to discuss about the classical bit, single qubit, multiple qubits. In addition, I am also going to discuss about the matrix representation of multiple qubits using these different states, and to check whether the given state is entangled or not for multiple qubit point of view. First, coming to the classical bit. As we know that classical bit is the basic unit of information in a normal computer. It's a basic unit. It is used to store the information or process the information in normal computer. We have two different types of bits. One is 0 or 1. So the information can be stored either in 0 or 1, but not both. This is the basic relate to the classical bit. So the information may exist in the either 0 state or 1 state. The classical computer processes the information using the combination of the combination of many bits, based on the data what we have given for the computer. For example, single bit have two states like 0 or 1. Similarly, if we have two bits, we have four possible states: 0 0, 0 1, 1 0 or 1 1. Similarly, in case of 3 bits, we have 8 possible states starting from 0 0 0 to 1 1 1. So the formula 2 power n, that is, if n bits, we have 2 power n states. For example, 1 bit 2 power 1, 2 bits 2 power 2, 3 bits 2 power 3. But the system, whatever the system in case of normal computer, is in only one combination. For example, if the process is like a sequence manner, in case of 3 bits, either it may available in the 0 0 state or 0 0 1 or 0 1 0 or 1 0 0, similarly like this, but not combination. So the system is in only one combination. So this is the theory related to the classical bit, and it is the difficulty related to the classical bit while processing the information for multiple data point of view. Because it's a sequential manner, we need to check each and every position or state to get the information or to process the information. It is one of the time delaying and difficulty in processing. And coming to the qubit point of view, as like classical bit, qubit is also basic unit of information, in quantum computing to store the information or process the information. Unlike classical bit, as I mentioned in the classical bit point of view, the state is either available or 0 or 1 in case of classical, but versus quantum point of view, qubit point of view, so either state may available in the 0 state or state 1 or both. This both is called as superposition. So the quantum bit can available in this 0 state or the 1 state or both states. Whereas in case of classical bit, both is not possible, any one of the state. Either it may be available in 0 or 1, but here it may available in the 0 state or 1 state or both state. So, and the quantum bit can be represented as psi is the state representation for the quantum system, alpha state 0 plus beta state 1. Here the state 0 and state 1 is the combination. Here the alpha and beta, alpha is the probability amplitude of state 0. Similarly, beta is the probability amplitude of state 1. Here the alpha, beta are like complex numbers, and it follows the condition like normalization, alpha square plus beta square must be equivalent to 1. This is a condition for normal. The sum of all the probabilities must be equivalent to 1. Here the alpha square is the probability of state 0 and beta square is the probability of state 1. And this, in general, this system represented in the complex coordinates. So, and the representation of the qubit and operations on the qubit, understanding based on the mathematics in complex space is difficult. That's what the Bloch introduced a Bloch sphere method to represent the any single qubit position visually. In this, he just taken a spherical model. In the spherical model point of view, each and every qubit position is represented as a point on the surface of the sphere. And in general, this state psi is represented like cos theta by 2 states 0 plus e power I phi sin theta by 2 state 1. Here the theta and phi are the angles related to the position state vector. Theta is the angle made by the state vector from the z axis and phi is the angle made by the projection of the state vector from the x-axis. This is called as polar angle. This is called as azimuthal angle. If you take like a theta 0 and phi is 0, then this is the north pole. North pole is represented like state 0 and south pole is represented like state 1. In any other combination, it's called it as like a superposition of both. Simple. This Bloch sphere model is used to represent visually on the sphere. It is one of the easiest way to understand the representation of the psi and operations on the psi. What happened if the quantum gates operate on the particular system, how it changes, and it can represent it as the rotation of the rotations on the Bloch sphere. This is one of the easiest way to understand the single qubit representation visually. And coming to the multiple bit point. Coming to the multiple bit point of view, it is one of the little bit difficult to understand multiple qubit point of view. In general, in case of single qubit point of view, there is no much advantage for the quantum computing. But when multiple qubits combine, the system becomes very, very powerful as compared to the classical computer. For example, it is very powerful in case of multiple bit point of view. For example, two bits in case of classical computer, we are having like in case of classical point of view as discussed in the first part, 0 0 0 1 1 0 1 1 are the states. We have to check each and everything individually one after another. That is the system of information stored at any particular state at a time. Whereas in case of quantum bit point of view, in case of 2 qubit point of view, these represented as state 00, state 01, state 10, state 11. But the advantage of quantum computing is it's not individual, it is represented as superposition of all these states like alpha, state 00, beta, state 01, gamma, state 10, delta, state 11. Here the alpha, beta, gamma, delta is the probability amplitudes relate to the state 0, 0, 0, 1, 1, 0, etc. And the condition like, it also follows the condition like normalization. Alpha square plus beta square plus gamma square plus delta square must be equivalent to 1. This is about the representation of the multiple two qubit state. It's like superposition of all the available states. Here 2 qubits, we are having 2 square, that is the 4 states. The 4 states are like this. And the matrix representation of the qubits, we follow the tensor product in the representation of the multiple qubit system. As we know that the basic basic states 0, 0 is represented like a 1, 0 matrix, and state 1 is represented like 0, 1 column matrix. And coming to the here the state, if you want to take the 2 qubit point of view, we have the states of 0, 0, 0, 1, 1, 0, 1, 1 states. Coming to the how to write the 0, 0 state matrix, we need to take the tensor product between these two, 0 state and another 0 state. So this 0, 0 is nothing but 1, 0 tensor product with the another 1, 0 matrix. So the product like 1 into 1, 1, 1 into 0, 0, 0 into 1, 0, 0 into 0, 0. This is the matrix relate to the 0, 0 state. Similarly, if you want to represent like a 0, 1 state, we need to take the tensor product between the 0 state and 1 state. As like previous, we need to take the 1, 0 tensor product with the 0, 1. So this is like matrix like 0, 1, 0, 0. So similarly, 1, 0 is nothing but 0, 0, 1, 0, and 1 is nothing but 0, 0, 0, 1. So then finally, if you want to represent the combination of all the state psi like alpha state 0, 0 plus beta state 0, 1, gamma 1, 0 state, delta 1, 1 state, by representing all these things in case of matrix, it's showing like alpha, beta, gamma, delta. This is a representation relate to the matrix representation relate to the 2 qubit system. Coming to the 3 qubit system. 3 qubit system. Coming to the 3 qubit system, we are having the 2 power 3 8 states, and it is represented like state psi is equivalent to alpha 0, for example 0, 0 state plus another alpha 0, 0, 1 state, because as previously in case of 2 qubit system, I can easily mention like alpha, beta, gamma, delta. Here 8 different parameters are needed. That's what I just mentioned, like alpha suffix 0, 0, 0, 0, 0, 1. Similarly, etc. alpha of 1, 1, 1 state like this. So this superposition of all 8 states. Here also the formula like all these parameters are complex quantities, and it is also follows the normalization quantities like alpha 0 0 square plus alpha 0 0 1 square plus so on alpha triple 1 square, which is nothing but equivalence to 1. Here, how to represent the matrix of 0 0 0 state? As we know that 0 0 state added with the another 0 state. Previously, we measured the 0 0 0 state in case of 2 qubit, that we are getting answer like this 1 0 0 0. It is tensor product with the another 1 0. This gives the information like 1 into 1 1 0 0 0 1 0 0 0 0. Similarly, we are getting 1 2 3 4 5 6 7 8. This is a matrix for the 0 0 0 state. Just like tensor product of individual states, we need to consider. And coming to the one of the most important topic for the quantum computing, that is entanglement. As we know that interference, superposition, and entanglement is differentiate the quantum computing with respect to the other state. Entanglement is nothing but if you change, that means the states, the two individual states are linked together. If any changes happen in the first state, that is also changes the second state. That called as entanglement. There is a link between the state 1 and the state 2 wherever it is, if the both are separated with very far. How to check whether the states are entangled or not? By using the state point of view. For example, if we can separate the total state, if we can, for example, the state 0 0, if you able to separate it like 0 and 0, if we can separate the state into first qubit and the second qubit, then these two states are not entangled. If you able to separate the combination into the two individual qubit states, then that particular state is not entangled. If it is impossible to separate the multiple qubit state into individual states, that is called as entangled. For example, state A, B, we are unable to separate it like A tensor product with the state B. So if you are unable to separate these two, then it called as entangled state. I will explain with a certain example. For example, consider the 2 qubit system. Just take it as 2 qubit system. We are having the state 0 0, state 0 1, state 1 0, state 1 1. We are having 4 states, and I just take the superposition of two different states. The position is like state is representing 1 by root 2, state 0 0 plus state 0 1. This is the given system to check whether the system is entangled or not. Now I just take it as 1 by root 2. Here the state 0 0, I just take it as state 0 tensor product with the another state 0, plus here this one is also state 0 and tensor product with the state 1. Here we are having state 0. Here also we are having the state 0. I just take it as like a common parameter, state 0 tensor product with the 1 by root 2. Here it is state 0 plus this is related to the state 1. So here this is the representation of one particular state like 0 state. This is also representation of the another state. So these are the two individual sources. This is the basics like a state, quantum state. This is the superposition of particular state because it follows the normalization condition, and 50-50 is the probability. So 1 by root 2 is the probability amplitude for this particular combination. 1 by 2 is the probability for the state 0 and the state 1. So this is the individual state. This is also individual state. So this particular system is not entangled. So the state 0, 0 is not entangled with the 0, 1 state. Similarly, for the given system like psi 1 by root 2 state 0, 0 plus state 1, 1. This is the system he given. He is asking about the check the system is entangled or not. First I am checking the possibility 1 by root 2 state 0 tensor product with the another state 0 plus state 1 is entangled with the state 1. So there is no other combination to take the common parameters and to make it as like a two individual states. It is impossible to separate the total system into the two individual sources. There is no factorization is possible. Then obviously the given system is entangled. The given system is entangled. We have to think about the state AB is not able to write like state A with the tensor product with the state B. Because of this, the given system is entangled. Whatever the changes happen in the state 0, 0, that changes the state 1, 1. So this is the representation of the matrix form for the multiple qubit system. And in addition, we can also check the system is entangled or not. So coming to the conclusion point of view, in case of classical bit, the state is possible in only one particular, that means the storage or the process information is like a sequence manner. The system is possible only in one state, either 0 or 1 for the single, or in case of 2, 0, 0, 0, 1, 1, 0 or 1, 1. In any one of the state is occupies and remaining is not used. So whereas in case of qubit, it is like a superposition. The state is represented like alpha state 0 plus beta state 1. It is for this single qubit. Here, one thing we need to understand, the quantum computing is not designed for the simple storage of information or naming of records, because the single qubit point of view, there is no much difference is observed when we are comparing with the classical bit. But if you take it as like a multiple qubit point of view, the real power of the quantum computer is added. Because in case of huge data, getting like information or taking the output from by checking all the different states is very difficult in case of classical computer. That is the added advantage for the superposition, because all the states are simultaneously checked and then it follows the condition like interference, and then it will give the end result, either it might be 0 or it might be 1. So coming to the qubit, and this single qubit is represented by using the Bloch sphere to understand the position of the single qubit on the Bloch sphere by using the spherical coordinates and the real world. And whereas in case of multiple qubit